Hello students, welcome back to the session. In the last session, we were talking about De Morgan's theorem, right? And we had stated both the theorems also. And the other thing that we did was proof. As we had already said, there are three ways of proving. That is using the algebraic method, using the proof by perfect induction method, and using the truth table. We have already used or showed how to prove using the algebraic method. Now let us prove the theorem using proof by perfect induction method. Okay, now let us start the first statement, that is x plus y the whole bar equals x bar into y bar. What you mean by the proof by perfect induction is by substituting the values of any one variable as either 0 or 1. We are using only 0 and 1 because these are the binary values. Okay, so now if x is equal to 0, then you have to show that x plus y the whole bar is the same as x bar into y bar. That is, LHS should be equal to the RHS. Now what we are going to do is we are going to substitute the value of x as 0. So 0, instead of x we are taking it as 0. 0 plus y the whole bar equals 0 bar into y bar. So what is 0 plus y? 0 plus y is y bar, right? And 0, what is 0 bar? 0 bar is nothing but 1, because the complement of 0 is 1. 1 into y bar. So y bar equals y bar. So the LHS is the same as the RHS, right? So this is one part you have proved using x equals 0. In the next statement, let us take if x equals 1, then x plus y the whole bar should be the same as x bar into y bar. So in place of x we are taking the value as 1. 1 plus y the whole bar equals 1 bar into y bar. So what is 1 plus y? According to the Boolean postulates, you have 1 plus y means 1. 1 bar equals, what is 1 bar? The opposite of 1, that is 0. 0 into y bar. What is 1 bar? 1 bar, that is the opposite of 1, that is 0, is equal to 0 into y bar. Whatever the value of any variable multiplied by 0 is 0. So 0 equals 0. So LHS is equal to RHS. So this is the proof of the first statement in De Morgan's theorem. Now let us go for the second statement, that is x into y the whole bar is equal to x bar plus y bar. Right, now if x is equal to 0, then, so as we said earlier, substitute the value of x. We have to show that x into y the whole bar is the same as x bar plus y bar. In place of x, you are taking the value as 0. So 0 into y the whole bar is equal to 0 bar plus y bar. So what is 0 into y? Any variable multiplied by 0 is 0. 0 bar is equal to, what is 0 bar? That is 1 plus y bar. 0 bar means the opposite of 0, that is 1, is equal to any variable, that is 1 plus x or 1 plus x bar is the same as 1. So LHS is equal to RHS, right? In the same way, substitute the value of x as 1. So x into y the whole bar equals x bar plus y bar. So the value of x should be taken as 1. So 1 into y the whole bar is equal to 1 bar plus y bar. So what is 1 into y? Is y bar, right? And again 1 bar means 0. 0 plus y bar. So y bar is equal to any variable that is added to 0 is again y bar. 0 plus 1 or 1 bar is 1, right? So y bar equals y bar. So LHS is equal to RHS. Hence you have proved both of the De Morgan's theorems using perfect induction method. Now let us go for the next method, that is using the truth table method. Now the first statement, x plus y the whole bar equals x bar into y bar, right? So now take, how many variables do you have? 1 and 2. So x and y, and then you need x plus y, and you need x plus y the whole bar, the LHS, and the RHS, you need x bar, you need y bar, you need x bar into y bar. Draw the table. So you have 4 variables because values, probable values, because x and y are 2 values. So that is 4. 0, 0, 0, 1, 1, 0, 1 and 1. Now, what is 0 plus 0? X plus y. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. X plus y the whole bar means the opposite of x plus y. That is, if this is 0, this becomes 1. 1 means 0. 1 is 0. 1 means 0. Opposite of 1. Okay. In the same way, now you take the value of x bar, that you have x, the complement of x, that is the opposite of x. If x is 0 here, x bar becomes 1. 0 means 1. 1 means 0. 1 means 0. In the same way, go for y bar also. Take the opposite of y. 0 is 1. 1 becomes 0. 0 becomes 1. 1 becomes 0. Now multiply these two. X bar into y bar. So 1 ones are 1. 1 into 0 is 0. 0 into 1 is 0. 0 into 0 is 0. Now check these two columns, it is the same, so hence proved. In the same way, go for the second statement, x into y the whole bar is equal to x bar plus y bar. So again 4 variables, x into y the whole bar, x bar, y bar, x bar plus y bar. 0, 0, 0, 1, 1, 0, 1 and 1. Okay. X into y. 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. Okay. Next, x into y the whole bar, that is opposite of x into y. 0 becomes 1. 0 becomes 1. 0 becomes 1. 1 becomes 0. Then x bar, the opposite of x here. That is 0 becomes 1. 0 is 1. 1 becomes 0. 1 becomes 0. In the same way, go for y bar here. Opposite of y. 0 becomes 1. 1 becomes 0. 0 becomes 1. And 1 becomes 0. Now add these two, x bar plus y bar. 1 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is, 0 plus 1 is 1, 0 plus 0 is 0. Now this column and this column is the same. So x into y the whole bar is the same as x bar plus y bar, hence proved. So this is how you are going to prove the De Morgan's theorem in 3 different ways. Okay, now let us go for the next. In the same way, if you are going for 3 variables in De Morgan's theorem, that is x plus y, you had for x plus y. Now if we have 3 variables, x plus y plus z, then this becomes x bar into y bar into z bar. And in the same way, the second one, that is x into y into z the whole bar, will become x bar plus y bar plus z bar. This can continue for as many variables as you want to, up to n. In a similar way, you continue. Now, one another important part is, what are the applications of De Morgan's theorem? Where are you going to make use of this De Morgan's theorems? So, this De Morgan's theorem, as we have talked already, it is used for simplification of Boolean expressions, which is used in digital circuits. Okay, and it is used for text searching. It is used for text searching using Boolean operators. Using Boolean operators. Which are the Boolean operators? That is your and, or, not. All these are the Boolean operators. And also it is used for mathematical duality. As we said, the principle of duality, right? So it is used for mathematical duality. This is what are these are what the applications of your De Morgan's theorem. Now let us go for the next step. As we said, why is De Morgan's theorem used? It is used for the simplification of Boolean theorems. Now let us go for one of the methods, that is simplification of Boolean expression using algebraic method. Okay, how are you going to simplify? You already know the simplification part, you are done in algebra, but here we are going to use the Boolean method. That is, you are going to use the Boolean theorems here. Now the first thing, a plus b into a plus c. Simplify this. Now for the first step will be the simplification, that is you remove the brackets, the multiply. Now what are you going to do? A plus b into a plus c. So multiply this now. A into a, right, plus a into c, plus this to a into b plus b into c. Now what are you going to infer from this now? What is a into a? A into a is a. That is a, if it is equal to 0, then if you are multiplying it twice, a into a, that is 0 into 0 will be 0. That is again a value of a. If a is equal to 1, then a into a means 1 into 1 equals 1. Again the value of a. So it is same 1. So a into a is a, plus a into c, plus a into b, plus b into c. Now what is common in these two? You can split and simplify. What is the common factor in a and a plus c? A is the common factor. You take it as a into what remains here now, when you take a common, 1, plus c, plus a into b, plus b into c. The next step, what is 1 plus c? 1 plus c is nothing but 1. It's similar to your 1 plus x is equal to 1. That is the properties of 0 and 1. Right? So, a into 1 plus a into b plus b into c. So, a into 1 is nothing but a plus ab plus bc. Right? Now, take these two variables. What is common? A. If you take out the common factor, what remains? 1. 1 plus b plus bc. So what is 1 plus b now? 1 plus b is nothing but 1, the same way. So a into 1 plus b into c. So a into 1 is a plus bc. So this is your answer. That is a simplified version of a plus b into a plus c. Now let us go for the next sum. X into x bar plus y. Simplify, that is remove the brackets. What does this become? X into x bar plus x into y. So what is x into x bar? If you have learnt already the complement rules, x into x bar is always 0 using the complement rules. So 0 plus xy. So the answer is x into y. Okay. Similarly, one more sum. X, y, z plus x, y, z, w plus x, z. Okay. Now, how do you solve this? What is the common factor among these two? There is no y's here, so we are not taking this. Just consider this. So, x, y and z are the common factors. So, what remains here? 1 plus what remains here? W plus x into z. So, x, y, z. 1 plus w becomes 1. Right? Plus x into z. So, this becomes xyz plus xz. Now, the next step, What is common in these two? X and Z. What remains here? Y. Y plus 1. So X into Z into 1. 1 plus X equals 1. X plus 1 equals 1. The rules of 0, properties of 0 and 1. So this is X into Z. This is your answer, simplified answer. Now let us continue with the sums in the next session. For this session, let us stop here. Thank you.